Hello everyone, this is Shentong. Today I would like to share our work, localizing visual sounds the easy way. So in this work, we are targeting the unsupervised visual sound localization. Our goal is to train a model that is capable of localizing sound sources in a video without relying on any ground truth bounding boxes of segmentation maps during the training. So there are some prior work, but they have limitations. The first one is that those audiovisual correspondence methods does not work well on this task. And the second one is that some new methods use the cross-modal attention before matching, but it presents a paradox. Since accurate localization is required to learn representations that match the audio to the right regions in the frame, and accurate representations are required to localize sounding regions. And the third limitation is that prior work often ignores the visual prior of likely audio sources by only relying on the audiovisual similarity for localization. So in this work, we present a simple but effective method, which is called EasyVSL. So our EasyVSL are mainly composed of three parts. The first part is the audiovisual feature extraction, where we use the audio encoder, visual encoder to extract audio-visual features from each modality. And the second part is the multiple instance contrastive learning. So here we have an assumption that sound sources is often visible somewhere in the video frame. So our idea is to align the audio representation with at least one of the localized video representations. So our goal is to maximize the cosine similarity between global audio feature and one of the local visual features. So we compare our MICL with the global contrastive learning and average MICL. So you can see the red bars, our MICL achieved the best performance compared to other contrastive learning frameworks. So the third part is the object-guided localization. So why do we use OGL? So OGL is a strong prior because most sounds are produced by objects, and it is very easy to incorporate such a prior during the inference. We can use a pre-trained model to guide the model for localize the object without any supervision. So we merge the audiovisual localization map with the object-guided localization map during the inference with a hyperparameter alpha. So in terms of alpha, we compare different values for audiovisual localization and OGL. So you can observe that when alpha is equal to 0.4 and 0.5 for each dataset, the OGL, so our EasyVSL, achieved the best performance compared to OGL and audiovisual localization only. So in terms of experiments, we also compare our framework with other approaches as the pink bars showed. So our EasyVSL achieved the best performance compared to other approaches. So here are some localization results for OGL, AVL, and our EasyVSL. So here's more the four models visualizations for the localization results. So in summary, our contributions in this work is to devise a simple but effective approach for visual sound localizations, which are composed of two main parts, multiple instance contrastive learning and object prior. So also we have some limitations in for this task, and the model is often easy overfit due to the outlet darping, and we also have high false positive rates. And thirdly, we also have small sounding objects which are very hard to localize. So that's all for our work. Thanks.